find the cotangent of an embedded function, which is going to require the chain rule. So the way I explain this to my students is that this is the outside function, this cotangent of something. And its derivative, which is what you need to start with, is the outside function. Its derivative, tangent secant squared, so cotangent is negative cosecant squared of whatever was in these parentheses, whatever you started with. So this is the square root of 3x. But then you need to use the chain rule to make this derivative correct. Now, the chain rule is what you do with this inside function. But this inside function is also composed of an outside function. So the outer one here is the square root, and it has its own inner of 3x. So when we go to do this chain rule, when we do the derivative of the inside function, it in itself has its own chain rule. So the derivative of this function for the outer part is the 1/2 times whatever was in the parentheses to start with, raised to the minus 1/2. That's the general power rule. But then it has its own inside function, which is this 3x, and its derivative is 3. And now you have the full derivative. And it seems like most teachers, professors, want this as concise as possible. So here's a 3. Well, let's look at it. Let's do it this way. The stuff that's on top is this 3, this negative, this cosecant squared of the square root of 3x. So those are on top. This 2 is on the bottom. And because this has a negative 1/2, that puts a square root of 3x on the bottom. Now, you can't cancel these. This square root of 3x is forever permanently attached to that cosecant squared. It's not a multiply. That is the argument of the cosecant squared function. These are inseparable. So there is no further simplification that you can make. And this final answer is negative 3 cosecant squared of the square root of 3x all over 2 times the square root of 3x.